Go ahead. Go ahead. Let's go ahead and start.
All right. So, how is everybody doing? And this is George, and today we are going to cover the last part, which is the section 3 of programming in Python. And what I'm going to do today will be pretty much walk us through step by step through some of the codings. And I'll go ahead and get started sharing the screen so we can go into that pattern. So if you look, let me see, share.
Okay. Yeah, I was going to say you're not sharing your screen.
That's right. So you look on this particular screen here, you see there's one aspect of it, which is build a stock prediction program.
Mm-hmm.
And then we are also going to talk about the web scraping using Beautiful Soup and requests library. And I also would like us to cover a little bit of email spam filter. So these codes have already been done. So what we are trying to do here is basically to just walk through the code and see what they do. And in case you have any questions, then I'll be able to answer those. And then we also have the machine learning. I don't think I'll cover this though, but as just for maybe I'll share. If you give me your email, then I should be able to share this particular data with you so you can run it on your own. But we will definitely cover that number one here, prediction for stocks, then web scraping, then email spam filter. Now there are certain terms which we will have to use though. So let me see if you can you guys see my screen? This one?
I can see.
All right, so like I said, it's going to be Python programming code walkthrough. And then there's certain things we need to make sure that we understand. First of all, we'll, for example, be using regression to make predictions, which doesn't necessarily mean involving predicting the future, but instead, you predict the mean, okay, so to speak, the average of the dependent variable given specific values of the dependent variable. So it's the X and the Y axis, okay? For example, we use one independent variable to predict the dependent variable. So we can use several values for the input, and then we do some data munching, and then we see what it can come out with to give us what we call the prediction. Now in machine learning, there's also the support vector machines, which are supervised learning models with associated learning algorithms, those which analyze data used for classification and regression analysis. So some of this might sound a little bit strange or unfamiliar to some of us, but like I said, machine learning and data science pretty much depends very much on mathematics, like the statistical aspect of math and also the computing aspect of it. All this combined with the communication, we are able to come up with what we call the data science or machine learning. Now with machine learning, okay, we have to have the data. Now that data, most of the time, it does not necessarily mean it's clean. So that means we have to clean it. And most of the time, cleaning the data takes a long time compared to even actually working with the data itself. So most of the data scientists take a lot of time just to clean the data, okay? So now we have another terminology, support vector machine. It can also be used as a regression method. So we can use either the linear or the support vector machine. And you'll see some of the coding examples in reference to this in particular. So this maintains all the features that characterize the algorithm. For example, the maximum margin. It could be to the margin of error of say 0.2 or 0.3 or 3% or 2%. So sometimes you hear when, for example, when they do the polling on typical example being politics, they say he was ahead by maybe 43%, but the following person was following closely at 40, let's say 42%, and then they give the margin of error normally between 2 to 3%. So that means it could have been accurate if all factors considered, assuming that everything is correct. So we know nothing can be perfect, and therefore we have to give it some kind of doubts. And that doubt we give it is what we call the margin of error. Now in support vector regression, as we will see, we use that for prediction, and we also use we use linear regression for also prediction. Now support vector regression, sometimes we refer to its acronym as SVR, which uses the same principle as the SVM for clarification, with only a few minor differences. So we will not delve into that, but I'll share the notes. So this is something you can basically do on your own and find out more about. And then I was able to capture a particular screen of just a tidbit of how some of these things work. So we always have the graph, we have the high, the low, and then we have something in the middle. So this will be able to give us some clear indication of how they do the calculation. So this might be too mathematical, so don't worry about it, but just for clarification and to give you what you're looking at. Okay. So like I said, Python, we use it for a lot of applications. One of the main uses we use Python for is for programming. Okay. We do it for digital forensics. Okay. And then we also use it for security analysis, as in socket programming, or as in port scanning, or as in geolocation. Now we have the latitude, the longitude, and then the IP address. So we can retrieve latitude, longitude, IP address, and the MAC address of a particular machine. For example, if you have a tool like that, say for example, you lost a laptop or you lost your phone. If you have an app which can be able to track that particular app has to have something to do with how it can be able to geologically locate the device based on the IP address, based on the latitude and longitude, the city and the state where that particular machine is at that particular moment. So long as the application in that machine for tracking it is turned on. So it can give you the MAC address, can give you so many other details to be able to determine and also to be able to know for sure if it's yours or not. Now, we use Python also for extracting data. We can do that for extracting like live data from Facebook, from Twitter, from Instagram, and from so many other social medias. So Python is a very powerful language, and we use it in so many domains. Among others, we use it for cloud computing, for big data analysis, for network forensics, for mobile app development, and for also web development and many others. Okay. Now, when you talk of digital forensics using Python, I know that takes us a little bit more. It could be for criminal, let's say, investigation, or it could be for, let's say, court cases to give evidence based on that. So we have the digital forensics, the cybersecurity, and the penetration testing. And we have so many tools built into Python to help us in doing exactly that. So among some of these, of course, in other languages and operating systems, we have Kali Linux, we have Metasploit, we have Perl security operating system, and many other tools which can be used for digital forensics. Now in Python, we have packages we can actually use which are already built in, which when used properly and programmed properly can also as well take advantage of what we have as the alternative. Now these tools come with built-in applications which the users deploy without real knowledge, because like we said before, Python come with packages. Now that makes it earn the name Python come already with batteries included. Okay, so we can the user can deploy without real knowledge of the internal architecture and algorithmic approach or implementation. Now, Python is widely used in programming for cybersecurity, penetration testing, and digital forensics. Okay, so some of the uses in particular, so we can use it for web server fingerprinting, for simulation of attacks, for port scanning, for website cloning, for load generation and testing of a website. We can create intrusion detection and prevention system using Python. We can also use wireless network scanning. Basically, we can develop a software for that. And then we can also do transmission of traffic in the network. Okay, access mail service, and many other implementation related to fingerprinting and security applications. So Python has all the batteries included. When you get it, it's ready to go. Just fire and just get started. And the good thing about it, it's high-level language, it's general purpose, it's very easy to understand, and pretty much the learning curve is almost flattened out. So one of the items we discussed is socket programming, which is already built in Python. So we use, just like in Java, but this one we use what we call, we have to install it, install the sockets. Okay, once it's installed, then we import it. So I'll just go ahead and demonstrate this. I mean, I'll show you this, but I will not demonstrate. This is something, if you have Python, you can basically run on your own and see how it works. So if we import the socket and then we say, now with the socket imported, then we call the method. You get the host by name, and you can basically not necessarily use Google here, but you can use any domain which you think you want to get IP address for. So you could be a good hacker or could be a bad hacker. But one of the best ways to be able to get information of a system, whether you want to attack it or you want to investigate or you want to help with, you have to be able to scan it and get the IP address if it's a remote system.
Quick question, George.
Yes, sir.
So can you also do the reverse? So you have the IP address and then you get the URL, the host name.
That's a good question, but I've never tried it, but that's something we can try and see if we can get the reverse. If you have the IP address, I believe you should be able to get the equivalent of the host name.
Right.
I don't have that, but let me look it up and then I'll answer you directly in your email.
Okay.
I think there should be a way of doing that.
Okay. Thank you.
And then once we go do the socket dot, remember we imported it. So we imported the socket. Now we say the socket, and then we chain it to the method. So socket being say a class, we chain it to the method, which is get host by name, and then the name of the host could be www.kenya.gov or whatever the domain that is. And then once you get the IP address, then you can basically do anything with it. Now, the next thing here will be, say for example, we get the IP address. What do you want to do with the IP address? We can ping the IP address. We can ping and inquire from the IP address what sockets they're using. And we can also find out among those sockets, let me take it back. What, instead of saying sockets, I'm gonna say ports. So you can ping the IP address and then bring it back and say, I would like to ping and be able to see what ports are open. Now, you know, basically from your knowledge that if you see certain ports which are open and insecure, then it will give you a very clear indication of how weak the system or how strong the system is. So that's one way of doing it. You can also import socket and then get the host name, get the host by name of your local machine. So you can do the socket.get host name and then you return the IP address. And then based on your IP address, you should be able to look at some of the ranges of IPs you have access within, let's say, your network. Okay. So go back to here, and then we can do port scanning. Generally in Python, there's a special library, which is known as the nmap. I'm gonna assume the N for network map. So the network mapping tool is used for the implementation of network port scanning. But using Python socket programming, it can be implemented without a third-party tool. So you have, first of all, you have to install it. Secondly, you have to import it, and then implement it, and then see what it does for you. So other than using that, we also have a very good tool, which is an operating system. It's a flavor, it's a distribution part of the Linux family of operating systems. And this is Kali Linux. There are many tools available for digital forensics in Kali Linux related to networks, but many of these implementations can be done using Python programming as well, with just a few lines of codes and instructions to follow those. Okay. So here is a typical example how you would probably scan a port using Python. So the first one we have to import. We import sockets, assuming that's already been installed, or it already comes with that particular machine ready to go. And then we can go ahead and declare a variable. We call the variable remote IP, and then we just give it a literal string, say IP address to be scanned, and then we do the port. This is a variable, and then we open an array. Now in that array, we give it array of numbers. These numbers are the ports we want to be scanned. And then we declare loop, and then we say in that loop, we want you to go over each and every port and return to us the results. So it will go and look at the ports, and then return the results, and then print it out here below. So from that, you'll be able to say, for example, save it in your local, maybe as a database, let's say in the database table, or as a CSV, or in Excel spreadsheet for later use. Okay. All right. So once we do that, now we always, when it's done, we have to close the socket we opened, so that we make sure that it doesn't use unnecessary resources. So we close that, and then of course, once we close, we'll be able to still see the results on the screen. Okay. So that's it for socket scanning. Okay, and also, I mean, for port scanning and also for programming sockets in Python. Now, alternatively, we can also do real-time location of an IP address. Okay, assuming that we have a range of IPs. So we went in, and then we say get host by name, return an IP address, and then based on that, we can use a Google library, which is GeoIP, I believe Geo for Google IP, which you can use this particular URL to consume, basically to bring it so that you can use it. And then once it's in your environment, you should be able to look up an IP And that IP address will be able to return for you the location of where the IP address is at. So once the database is loaded and mapped with the Python installation, any IP can be scanned with global visibility. Okay, unless, for example, let's say they for example, they hide it in one way or the other. Okay, they can masquerade an IP, of course, and that probably be one of the security features which probably most people should be looking at. Okay, but if it's not hidden, then you should be able to retrieve it and use it. Okay, now this is how you can do it from the command prompt, assuming that you have Python installed. Okay, now you can go import PyGeoIP and then declare a variable. And then based on what you import here, you basically say, now I would like to go ahead and call the GeoIP method of the PyGeoIP. And then you take this as a data set. Now the data set, you probably might have downloaded this from, say, from data.world, or you go to kaggle.com, or you might just be having your own way of getting this kind of data. If you have the data, then you should be able to look it up, and then it can return the IP address. It can give you the country where the IP address is located at. So you can look up the country, use the following command. For example, here, you can say, I want to import it, but I would like to be able to get where this is located at. So it brings back the IP addresses and then tell you where the locations of those IP addresses are at. So most of these will probably be in the United States, or you can ping. If you have an idea of anywhere else with a valid IP, you can look it up. Okay. So again, the geolocation, if you can see this one, it's going to be a Python code. Now you can look up the city, use the following, and then you basically consume this particular source of data, which you probably downloaded from somewhere, and then you want to be able to record by IP, and then record the city. Okay, in this case, it's going to be Mountain View for Google. The region is going to be California. The area code is going to be 550. And the time zone is going to be Los Angeles time zone. That's the Pacific time zone. And of course, there's so many other codes. I believe, I'm not really sure DMA code will be, but I'm assuming it's going to be something related to the location where they are at. And also, metro code is going to be San Francisco area, and then the country code, of course, the US, the latitude, the longitude. Yeah, the postal code, that's the zip code. The United States, the continent, for some reason, it's probably it's not coded, so it's not gonna bring it back. But that's how you can extract identity of a particular machine based on the IP address. Okay. Using Python, using the library for PyGeoIP once you import it. Okay. So I basically used some examples I found online here for how we can also extract or retrieve information from social media, from Twitter, YouTube, Facebook, Instagram. You can go to, let's say, particular website, you can go to Geolite Legacy Downloadable Datasets. Here you can download quite a variety of even the information for the IP geolocation and all that. So this is one area, Mr. Maranga. This is also an area where you can get some of the data sets out. So
which one is that?
This will be, I would probably say you go to Geolite Legacy Downloadable Datasets. Just Google that and then you should be able to probably it's going to direct you to another website, but this is also a place where you can do the download. And then if you do a successful download and then it's all on your end, then this is what you probably might be able to find. It can give you in the CSV. It's going to be, of course, zipped, and then some of them could be binary, and you can basically download it. So then you use it. So that's it for this particular one right here. And this was just an overview of what we are going to look at. Okay. So another area which is also very important will be to make sure you look at the Python package index. This is a software repository of a lot of Python packages for interfacing with other platforms. Okay. So P is known as PyPI, which is freely available for Python developers without any license. How beautiful is that? And then down below here, we can also do, for example, this one. We can do some of the following with Python. You can fetch a list of followers from Twitter using Python. You can fit a timeline for, say, for example, you want to look Twitter timeline for Mr. Donald Trump. You can use those, but you have to go to this website here and then download the library. I mean, the source code. And then once you download the source code and then you put it in your IDE, you should be able to run it. And you might need some other information, but based on those, you should be able to come up with something cool. Now, remember, some of the websites like Facebook, Twitter, they might need you to be able to sign up and get an API key and password. So be on the lookout for those just in case they need that. Okay. So that's it for this one right here. Okay. And, just in case you have any question based on that before we continue?
Not from me.
Okay. All right. So let's go ahead and we are going to go ahead and do the email spam filter. Now, this program detects if an email is a spam or not a spam. If it's a spam, it's going to be 1. If it's not a spam, it's going to be 0. Now, the email spam detection is using Python and machine learning. Okay. Now, I know it's confusing sometimes. We are using Python programming language, but we are applying Python as we know it in machine learning. Now, machine learning will basically, when we do it in Python, will come with some libraries which we will never be able to ignore. Some of the very famous ones, which we also talked about in the previous videos, was NumPy. We talked of NumPy as a simple translation of numbers in Python. We will also use Pandas. Pandas is a library which also enables us to extract and manipulate data, large sets of data. It could be in the CSV we can read from or read to. Okay, and then we also talked about the natural language library. We call it the NLTK. So it's a natural language toolkit library, which we have to import in Python. And then once we do that, then there's a particular method in there. We call it the corpus. And then we import the stop words. Now, somebody may ask, what is corpus? Now, in the previous video, I basically gave a definition of corpus, but let me just, for clarification, let's go ahead and Google that, and then just to be on the, it's a very rare word we rarely use. So. Okay, So in linguistics, a corpus, or plural for corpora, or text corpus, is a large and structured set of texts. So corpus package automatically creates a set of corpus reader instances that can be used to access the corpora in the natural language toolkit data package. Okay, so stop words basically literally means words which, when they're in a sentence, for human, they're very good to have, like the word and, there, the word there, you know, very simple wordings. But in the data, in machine learning language, or this processing, we are going to do stop words basically mean useless words. Those words we are going to get rid of. And then when we import, also we have to import the string, because we are going to use a string library, which pretty much every word is a string, like the way they categorize. It's either variable, which is a string, or a numerical, or whatever, float, decimal, and all that. But this is a string we are going to use. So first of all, we have to go ahead and we are going to read. Whatever we read here will be emails, CSV file, which I basically got it in here earlier. So let's see if it's still there. Since I'm using Colab, maybe it's timed out, but I will have to import it again. So we go back in there. Okay, hopefully it's still there. And then once we import it, then we remember we use pandas. So in pandas, we are going to go ahead and say, for us to be able to bring this one up, we are going to print the first 5 instances of the record in that particular emails 2.csv file. So we click on that. And then if you look, can you guys see? Hopefully you can see. If you look,
I can see.
Okay. If you look, we have, remember, 1 for spam right there, 0 for no spam. Okay, so we have text, which is the category in the middle, the subject and the body of the email. So that's what we have in the CSV file. Now, the next thing we are going to do, we are going to say pf.shape. We are going to get like the number of columns and rows in that particular data set using pandas. We call it shape. So we click on that. Basically tells us we have a lot of rows and only 2 columns. 2 columns being text and spam. And we have 5,728 rows. That's a big set of data. And imagine in real time, this could probably be in the millions. So sometimes you just want to cut and only use what you want. So we come here and then we say, let's look at what columns we have. So we come here and then we execute pf.columns to just get the column. So it gives us a column. The column is text and spam. Okay. And then once we get that, then we come here and check for the duplicates and then remove them. In some emails, they'll be like, get a lot of emails from this. It's somebody trying to solicit so that you can buy their item they're selling. And it could be several emails of the same subject. So that's what we're trying to do here by making sure that we basically get rid of the duplicates. So when we come here, we say drop underscore duplicates, and then in place, if it's true, then get rid of it. So we come and click on that. So that's already been executed. And since we don't have a printout, it's not going to execute. You'll not be able to see it. So you don't have to worry about that. So, okay. So once we drop that, then we come to, we check, show the number of missing data. Now, sometimes when you look at the big data, it could be very corrupted data. So you see the NAN, NAN with capital A with lowercase a with just NA as in not applicable. So we want to go in and see if we have anything of that nature. So we basically run this one. And if it tells us that the text and the spam do not have that, then we are good to go. Then once we finish that, then we go to the next one. Now we say we want to download the stopwords package. So we go ahead here and then say, I did this. Now we downloaded package stopwords 2. It's already been downloaded to the root, which is where the location of the natural language toolkit library is located. So the package stopper is already up to date. So it's true. Okay. When you run that, telling you it's already up to date and it's true. So stopwords is going to be part of what's already in the library. That library has specific words. If it's in English, then you have stopwords. Now, what if you wanted to do this in Kiswahili? Then you have to come up with some stopwords and then you save them in an array somewhere so that when you're doing your natural language processing, then you'll be looking up at the stopwords and make sure that you eliminate them from what you're working on. Okay. So we come here and then we say, now we would like to go ahead and remove the punctuations. We want to remove the stopwords, and then we want to return a list of clean text words. So whatever we return will be clean and good to go. We say we are going to go ahead and declare a variable. We call that variable no punctuation, so we just say no punc, and then character for character in text, if character not in string, punctuation. Okay, so that's basically, that's an array right there. So we go look in the array and then we bring it up, then we save it in no punc. Once we do that, then we use the same punc. Now we overwrite the variable. The memory location, that variable is going to clean it, and then we are going to populate it something new. So we join whatever we get, and then once we use a join is part of the data set, the part of the pandas library. So we join everything together, just like bring them, everything, bring them together. Then once you join them, then we keep it in the punc, no punc variable. Then we go ahead and declare another variable. We call it clean words. Now in the clean words, we say word for word in no punc, and then we split them now. Based on the spaces in between them, we don't want them to mash all together, so we split them up. And then whatever we do, just remember it's all in English. If it was not in English, then we put that particular language in there. It could be Arabic, could be something else, could be Japanese, could be English, another type of English, maybe Australian, could be United States English, or could be Great Britain. So there are so many dialects, like in so many other languages. So whatever you do, you really have to know what you want to be able to get the right results. So once we do that, then we come back here and then we basically return the variable. So this is a function right here. In the function, we say, call it process text. And then we give it a parameter. The parameter is a text. Once we do that, then we come here and then we return whatever we processed, return it back. And then once we do that, now we would like to show what we came back with. So we run this. Okay, so it's run. So we know it's good to go because we didn't get any error. Now we are going to give it some fake, basically we're just making up some words. So we have hello world, hello, hello, world play, test, 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 one, hello. So when you look here, we have basically two words. We have hello world, we have three words actually. We have hello world, and then we have play. And then here we have the word test, and then we have the word one, and then another hello. So we print here, we see what it does. It's gonna come up with hello world, hello, hello world. Okay, so whatever we did here, we saved it in here for the first one. What if we don't want that? Then we can go ahead and comment it out. Then we run it again. So that's good to go. We just comment that out because we don't need that either. And then we come here. Now we convert the text to a matrix of token counts. So we call the sklearn. Sklearn is last time we mentioned it is one of the artificial intelligence Python library. Okay, we use a lot in terms of processing and in terms of predictions. Okay, and regression analysis. Okay, so we say from sklearn.feature. So we extract feature underscore extraction of text, and then we import the count vectorizer. So we go ahead and do the counting, but we bring the import, we import part of that, which is known as vectorizer. So whatever we do in the vectorizer, we go ahead and say we want to create a new variable. We call it bow4, for example. Could be a bowl of words. And then we say count the vectorizer. This is a method. So inside that method, we are going to call analyzer equals to process the text. Okay. And then we say we want to fit and transform that message 4 right here. In here, and then message 5. So we call those, both of those, and then we put them in here as arrays. Now for your own time, I mean at your own time, for your own sake, look up the word dictionary and also look up the word tuples and list. Those are data structures in Python. So they'll be talking of tuples, lists, and dictionary. Now, if you're familiar with any other language, we call, for example, this one we'll call array. Now in Python, it might be called differently, but it does more or less the same thing. So when we do that, then remember we have, for example, here, when we click that, it runs, and then we have 3. So we have 1, 2, hello, world, those are 2. And then which do not repeat, the last one is 3. And then we go ahead and do another one again, then it tests. So it tests the occurrence of those words in individual arrays, and then brings it back here so that we can see. Now, once we do that, then we go ahead and call the bowl of words 4, which is a variable, and then we look at the shape. The shape is a method in pandas, which basically bring to us the number of columns and the number of rows. So we have 2 columns, text and spam, and then we have 5, 1, okay, 1, 2, 3, 4, okay. We have 5, so, okay. Let me go back. We have 2, text and spam. So if you look in the bow, then you go back up here, we have 1, 2, and then we have 1, 2, 3, 4, 5, which we returned in the header. And that's what it gives us back here, okay? And then we basically know now that we have what we're looking for. Now we are going to go ahead and convert a collection of text to a matrix of tokens. Okay, so we call the library sklearn.feature extraction text, and then import it. We do the same, whatever we did up there. And then this time around, we are not going to go ahead and return the messages, but we instead return the text, okay, which is up here. Okay. So run on that. Might take a few minutes based on how machine is quick on the Google end. The reason why I used Colab is it's faster compared to some of the major data sets we were going to use locally. Okay, while that one is still going, so we expect it to be able to come up with some, without any error, but come up with basically with something and then save it in the message ball of words. Okay. Once we get that, then we are going to split the data into 80% training. Now we are going to train the data. We say, I have a bunch of data. I would like to be able to take 80% of that, say 8 out of 10. We are going to put aside for training, and then only 2 out of 10 is what we are going to use for testing. So that's what this one is all about. So we call sklearn.model select, and then we import train test split. And then we say we are going to, remember we have the Y and the X axis. So in the Y axis, we have the train, and also we have the test. In the X axis, we also have the train and also the test. So we basically go ahead and say X train, comma, X test, and then Y train, I'm sorry, X train underscore, X underscore train, comma, X underscore test. So whatever we have is going to be 80% in the training, 20% in the testing for the X axis.
Hey, George.
Yes.
So where did you get your X, Y axis? Did you get them from the columns that you had earlier?
No, so when we call the NumPy, the NumPy is gonna be subdividing this data into what we call an array. Now, array, remember, will be X and Y, right?
Right.
Of numbers. So when we call the sklearn feature extraction text import, and then we do the counter vectorizer, we are going to look at this data in linear or SV regression. Now remember, when we started, I mentioned about the dependent and the independent variables. So there's the X and the Y axis. And that's how we're going to be looking at the data which we get in. So out of the X, we have 80 and 20. Out of the Y, we also give it 80 and 20. So remember, the 80 is going to be for training, and the 20 will be for testing. And that's where we come up with the X and the Y. So whenever you use the sklearn feature extraction text in this case, we have to be able to make sure that we call the train test. This is how we're going to be splitting the testing. Is that clear for you?
Yeah, sure.
So once we do the X train and the X test, we also do the Y train and the and the Y test. And then we call the method, which is part of the sklearn model selection. We call it train test split. It's going to take the message bow, which we originally have there, which we returned, and then look at the spam. So we return spam. Remember, we use a PF, which is right now is going to be an alias we declared for the pandas. So we call the spam here, and then we do the size 0.20. The test size is 0.20. Remember, we said the test is going to be 20%, which is also equivalent to 0.20. And then we are going to do the random state equals to 0 for now. Okay. Now we're going to run that. So it's gone, that is really quick. And then now let's go ahead and get the shape of message bow. So the shape will be again, how many columns and how many rows. So we basically return that in the thousands. So that's a pretty much a big data set. Now, the next step, we create and train the naive Bayes classifier. Now, last time we talked about Bayes, somebody who discovered something. Now, when you talk of the classifier, now the Bayes classifiers are used to benchmark in statistics or in statistical classification the excess risk of a general classifier. Now, possibly depending on some training data, is defined as, okay. Thus, this non-negative quantity is important for us assessing the performance of different classification techniques, okay. So we use that to go ahead and basically call that it's going to be part of the sklearn, and then import multinomial NB, and then we declare a variable called the variable classifier, and then we've already imported, now we call the multinomial NB, and then we basically chain it, and then we chain it to the method fit, and then we call the X train and the Y train. Okay, so once you do that, then we click on that, and then it's already kept it. Now we come and print the predictions. So remember, we are going to predict whether an email is a spam or an email is not a spam. So 1 will always be true, 0 is false. So in this case, we click in between these two numbers. When we click, print the prediction, but in between those range of numbers, it could be several hundreds of numbers, we have 1. So if you wanted to look at this maybe more in detail, it would be nice, but I'll send you the link so you can look at this privately at your own time, and then you do the analysis. Now we printed that, and then we also want to print the actual values. The actual value will be y_test, okay, dot value. So we can print that. Now, I would like you to compare with what if we did this. Let's, instead of printing y.values, let's go ahead and try that. See how you get the difference. So one is like a list, and the other one is a list within other lists. Okay. So go back there. Printing is just for basically to help us understand. You really don't have to print. You can just type if you're really sure what you're doing, and then come and run it. So here we want to go ahead and evaluate the model on the training data set. Okay, so we say import sklearn metrics, import the classification report, confusion metrics, and accuracy score. So we want to see, okay, how accurate is this thing? Now remember, when you flip a coin, we say it's 50-50. We don't know whether it's going to land on the head or it's going to land on the tail. There's no way you can say it's 75-25 because we still don't know. In this case, we want to be able to get the accuracy. The closer it is to 1, the more accurate it becomes. 1 being the most accurate one, 0 means no. So it's either true or false. So we say, go ahead and declare another variable, we call it pred for prediction, and then call the function or the method, classifier.predict, and put in there the x_train parameter, which we are declared up there, okay? So we bring it here, and then we say we would like to print the classification report, we would like to print the confusion metrics, we would like to also print the accuracy report. So when we do that, this is what we get. So we get the precision, it's pretty precise, almost a 1 or 0.99. You can recall that we get a 1 now. and then we get another, and then we get that support. So the accuracy, based on this, we have the 0.997% accurate, which means based on what we extracted and we used or consumed as the data, we have a very high chance of classifying that either it being a spam or it being no spam. So 1 is a spam. So that means the accuracy is 0.99%. If you round this, it's almost 1. Of course, it's going to be 1. Okay. Now, how the model really does on real data. So we print the predictions here. That's going to be long range, so you can look at that at your own time. And then we print the actual values, which is pretty much the same. So one will be the linear regression, the other one will be the SB regression. Now, once we do that, now we evaluate the model on the test data set. Now we import sklearn metrics, import the classification report, which we had already done up here. We're going to do it again here so that we can get a comparison between linear and SB regression. So we come here, we do the same thing, X test. Remember, this was X train. Now we work on the test. And then this one, we go ahead and do exact same thing. Classification, confusion metrics, and also accuracy. And then when we run that, you see this is, the number here is 0.997, while here is 0.992. So it's much more accurate up there than it's accurate down here. So evaluate the model on the test is less accurate than on the training. Okay, and that's is what it brings us to. So we can be able to use Python to filter email and identify an email as either spam or not a spam email. And that's the code. So I'll share with you this code. If you give me your email, I'll be able to send that to you so you can be able to get it. When I send it to you, if you have a Google account, if I send it to you, you receive it in your Google, just click on the link and then you can run it. You don't even have to type anything. So Scholar is almost like working with your say Google Docs. All right, so that's for the email spam. Okay, so do you have any other question here on this particular area before we go to the next one? Okay.
No, not for me.
All right. Anybody else? Any Ali, Rose, anybody? All right. I'm gonna assume you're good. Yeah, go ahead, please.
I was going to say it's a little complicated on the accuracy and
Yeah, it has to be. But again, everything here depends on how clean your data is. It really depends on how clean. Like, remember when I was telling you about some of our data from Kenya, you go to, I believe it's Open Data Kenya or something like that. So some of the data might be clean, but some of them might be manipulated. And I'm not saying everything is manipulated, but integrity in this case means a lot. It means a lot, especially when you really want to use that data. So the name of the site is opendata.go, which I believe is government.ke. You can get agriculture, education, environment. You can get energy, finance, governance, government accounts, health, no? So,
did you say opendata.go.ke?
yes. .ke.
Yeah, I'm having this website that launches with Tomcat.
Okay.
Yeah.
Did you make sure you punch in? Let me see if I can share here. Can you see? I'm going to put it here. Can you see that?
1 second.
Open data.
I can't see, I can only see your Python page.
Okay, it's here in the Python.
Oh, sorry. Okay. Yeah. Got you.
That's it.
Yeah. I guess what I didn't put is the www.
Yeah, so you know, it tells you what kind of server they're running, right?
Yeah. If there's any hackers, you can figure it out.
Yeah, so you can you can hack it from here. Okay, so that's good for that. Then let's go to the next one here. Okay. Okay, so let's go ahead and do the build a stock prediction program. Okay, this one is going to be a little bit different, and I'm sure you're going to enjoy it. So we are going to go ahead and use some libraries. One of the libraries which we have to use will be Quandl. Quandl is I would say it's relatively new, but not so much not very much used out there. But Quandl is very handy in terms of what it can do. And there's a website for them. You can actually go online and get more information or sign up for an API. It's a marketplace for financial, economic, and alternative data delivered in modern formats. Yeah, for today's analysts. Okay, so Robert, that's also another place you can get your data from Quandl. So here we have to import it. So what I did, I'm using Colab. So I went ahead and I did the pip install space Quandl. And then this is what it did. So if I do it again, then it will probably say it's already been done. Okay. Once we import that, then the next import will be NumPy. NumPy has to be part of this. And also we have to import sklearn because we are going to do the learning, the training, the learning, so that we can get the prediction. And then we are going to do the SVR, which is support vector model or support vector regression. So based on what we covered before, this is key when it comes to prediction, it comes to analysis, it comes to statistics. And also we have to also import sklearn selection and then import test, train, or train test split. We're gonna split it, could be 75, 25%. Then we work on that. Now, once we do that, let's go ahead and run to make sure it's working. So click on that. And then normally you want to do this so that you know for sure it's okay. When you don't get any error, that means we are good to go. The next thing, we are going to get the stock data. Stock data, we use a Quandl. Now, this is how you use a stock data extraction using Quandl. So we can say df for data frame variable equals to quandl.get. So when using Quandl, you'll always use the wiki. FB for Facebook can do / for Amazon, could be AMZN, I guess. It could be for Google. It could be for Microsoft. It could be for any other company. So they have the data. You can go as way back as when the companies got started the first time, when they went public. It could be for Apple. You can go back to 2012. You can go back to 2000, whatever is available. Sometimes the data might not be all 100% there because, for example, today is a Sunday. Markets are closed. So you might get some gaps. If you get data of that kind, you have to clean it up. When you clean the data, you make sure it's properly cleaned so that it does not give inaccuracy. And that's very important. Okay. So,
for example, there, what you're doing is you try to remove the empty rows or whatever.
Say one more time.
So for example, what you referred to, for example, today's Sunday, there's no activity, so there's not gonna be data for Sunday.
Yeah,
So you'll be removing probably empty rows or whatever.
that's right. So you might get something like NAN or some zero.
Right.
So you probably wanna, if you're dealing with numbers, you don't want any digit. I mean, you don't want any NAN, something which you cannot use. So you just go ahead and replace those with maybe zeros. So that's a good example. So once you do that, you call Quantum, you basically declare the variable df and then you call quantum.get. Get is a method, so it goes in there and then there's a wiki. Wiki, I believe, is a directory. Inside that directory, there's a Facebook, a Microsoft. There's so many of those, Google and all that stuff. So we basically go ahead and retrieve it. So we are going to go ahead and click on that. Brings it over. And then how can we tell? We have to print it. Now, remember, df data frame. df is for data frame here. It's a variable. Dot. Header is a method. Now the method here, we can pass a parameter to the method. We can say, for header, if we leave it blank, always going to default to 5 rows. But what if we want 10? We can put 10 there, and then when we click on that, we get 10. What if you want more? You probably want to see 100. Then you can just do that. Okay, so it's very intelligent, good enough to remember that it doesn't want to fill up your screen, but it said put you some dots. And then you can basically say 100 rows by 12 columns. So every data in here has 12 columns. It could be 5 rows, but always 12 columns. Now the columns will be the date, the open, the high, the low. Adjusted, low, adjusted, close, adjusted volume, and it goes all the way. So this is something you can also retrieve and print or download and see on your own, on your end. So let me see here. Okay, I'm gonna go ahead and do that. So when I send you this, you'll be able to get that information. Control. In Python, you have to document that. You have to put that number. Instead of most of the languages, they put / or whatever. So this one, we use that one. So once we do that, then we go ahead and say, okay, we just want to get the adjusted close price right here. This is all we want. We don't want anything else, okay? The close price, when they open in the morning, they open, and then when they close, the close price is gonna be the price we have here. So we call it the adjustable close price. So we want that, and then all we want to do, look at these numbers here. So we're gonna go ahead and click on that. Once we click on that, it brought it over, and then we click on that. Now that brings it to our screen. So we have the DF adjustable close, and then we have the DF header of the adjustable close. Now this, remember I said, by default, always gonna be 5 rows. If you needed more, you can say that, I need more, maybe 10, then you can get 10, okay? Now we want to predict the future value for stock prices in days, okay, into the future. And let me just say this for, for brevity. This cannot predict like in real time, but this is just an illustration. You probably need more data for you to be able to predict, but this is the basis of how you can do it. So don't take this as something which you can just run and then you predict a stock and then you go buy it. Then if it doesn't work, then you come back and say, George probably did not tell us the truth. No, I'm not saying this is what we can use, but this is just a model, something we can use to basically get a clear picture of what big is happening behind the scenes. So we can predict that, predict the future value of a stock, number of days, you can put it 30 days, 10 days, 20 days, but in the future, based on the historical data we have. Of course, we manipulate that using linear regression, the dependent and the independent variables. Then once you do that, now we go ahead and run that. So when we run that, we basically take number 30, which is 30 days, we save it in the forecast out. Forecast underscore out is just a variable, which we plan on using later on down the line. So we come here, and then we say we create another column. We call that the column, we're gonna call it adjustable clause. Now we create another column, the target or the department variable, shift number of ends, unit up. So we say here, DF is just the data, which we use the data frame. It's a variable, but we call it here. Now we say we want to replace whatever is in the clause, adjustable clause, bring it and then call it a prediction. Remember, this is one, right? This is one adjustable clause. But when we do this, it's gonna bring it two. So we're gonna have the adjustable clause, the same number, but it's gonna be having something on the next column. So we go ahead and run that. So we have the same number, and then right now we have the prediction. And then we say print the new data set for head. Yeah, you can do for head. The opposite of head is, of course, it's tail. So what if we wanted to see what's in the tail? We can say the tail. Remember, first of all, before we go there, let me show you. You see here. Now, when you go to the tail, the number of adjustable clause will more or less depend on the prediction we have here. But so far, we just shift the focus by 30 days. What if we did by 1 day, so we can just do it for clarity? Let's just do it for 1 day. And then run this one. Now, if you look here, this number here is that number. That number here is that number. That number here is this number. That number is that. So there's that correlation based on the shift we did, because we did the shift focus. Shift focus number of days. So shift focus 1, shift focus 2 could be 4, 5. So if we did it for more days, then you get a lot of no predictions. The more you go into the future, the less the prediction you have. But the less you go into the future, could be 1, 2, 3 days, then you have something to work with. Say, for example, we did that. Now let's go ahead and look at this one here. You see the number of nuns will be less. So say probably 1. So come here. So you see, the less you go into the future, the better for you. So if you go too way into the future, you might get all the nuns, and then you'll not be able to predict, say, in 45 days, buy stocks for. You just want to predict for tomorrow or the following day. So once we do that, then we create the independent data set, X. X is the independent data set. And then we convert the data frame to a NumPy array. Now we say the X variable equals to NP, which is NumPy, dot array, and then we call the data frame, but we're going to drop the word prediction here. We're going to drop it. So this is a list. We can do a list within a list, or we can do just a list. But I'll show you both so you can see. So once you do that, you go ahead and run it. And then this is what we get. That's a list within a list, like an array within an array. Yeah? Maranga, you remember that, right? Okay, so.
Yeah, I do.
Alternatively, we can go ahead and say, all right, So what if we just want just a simple array? This one will be horizontal. We can do that, then we run that, and then it gives you horizontal line. Those are, which are X, the X values. Once we do that, then we come here. I'm gonna go back to the original so we can use this one right here, the other X. So I run it again.
So
What?
George, as you go through the explanation, I'll be curious to know why you're using a list in a list.
Okay.
As you go, I don't mean to interrupt you, but I'll be curious.
Okay. So remember when sometimes the data could be a lot of data. So the best way, sometimes you want to make it simple, just run a list. But if you have to like use a lot of data over several years, sometimes it might be very confusing. So you want to use either a list or a list within a list. But this one, we are going to just use as a matter of convenience, we are just going to be able to just use this particular data here to be able to give us what we want. Now look, you see that? That's the first one. You see this? Adjustable close? That's the second one. You see the third adjustable close? That's the fourth one. Now, you might find out that this prediction here, if we want to be able to illustrate both, then we probably want to use a list within a list. Because first one will be showing us the adjustable close up here. And the second batch will be showing us the prediction right here. As you can tell, 164 is 164, 159 is 159, 160, 160. So this will be your preference. For me, I want to be able to show you so you can see all of them sitting side by side. So a list within a list or just one liner. So the detail is in the pudding. Okay? Did that answer your question?
Somewhat.
All right. You still have doubts? Maybe we keep on going, then you might get through as you go along.
Yeah, I think let's continue so we don't get distracted.
Okay, no problem. So we create the dependent data. Dependent data will be the y-axis. We convert the data frame to a NumPy array, all of the values including the nonce. Remember, the nonce might not be of any use because they're basically just a space occupier, a space holder. So we say, whatever we did here, we are going to do it here, but this one, we are going to use the y-axis. So we say np array dp, and then we do the prediction again, and then we see the y. So the number of days, and then we print it out. So when we do that, this will just be a list. Okay. What if we wanted to do the same, like we did that? Okay. So for now, this is probably simple to see and understand. But if you wanted to do, we just do that, and then we change the variable, which is going to be x. Instead of x, going to be y, and then we just do the same here. But when I send you this link in the code, then you can change that and see how it works. Once you get the x and the y, now we want to split the data into 80% training, okay, and then 20% testing. Remember, it's 80, 20, could be 75, 25, could be 100. No, I mean, both of those when added, they have to be 100. But training is 80 and then testing is 20%. So we come here and say X train, X test, Y train, Y test. And then we say equals to, this is right here is a method we call from sklearn library. And then we say XY, X comma Y, and then the size of the test, which is 20%. Now, if you remember what we did in the other program, is the same with the other email program, is the same thing we basically use in here. So once that means once you get one down, whatever kind of data I give, you can always do whatever you want to do so long as you have the correct data, because they follow a certain pattern. So here we can say maybe 75, 25. Depends on how accurate you want it to be. But remember, the data always has to be clean. You have to clean it. So we have it here, and then we say now create and train the support vector machine regressor. So we are going to go ahead and, okay, now we have the data. Everything looks good, but we have to train it. We have to train it to make sure that it understands what we want it to do. So we come here and say SVR underscore RBF, which is just a variable. It could be for just a variable to indicate the support vector machine we are going to use. And then we say into the kernel, RBF stands for radio basis kernel. Some of these might not be necessary, but let me go ahead and just say it. Now, in machine learning, the radio basis function kernel, or the RBF kernel, is the popular kernel function used in various kernelized learning algorithms. So when we're doing the learning, we have to use those. So this, we call the gamma, we call this one, and then we call the C equals to that variable, and then we call the gamma. So those will be part of the radio basis kernel. Now, if you feel like you want to read more about that, then let me go ahead and share with you maybe Wikipedia. Wikipedia might be able to help. So when I send this, you'll be able to see that in there. Now, once you do that, then we go ahead and say SVR, BRF, we fit the X train and the Y train all together, and then we run. Okay, where did that come from?
Remove the double slash probably. I think that's what is the double slash. Yeah, no, the double slash before the Wikipedia.
This one. No, this should not affect it though.
Run the cell above it.
Yeah, I need to run the one above it to make it good. So this can be detected because it's telling us X train is not being defined. So if it's defined here, then we should be good here. That should probably be fixed here, right? So it's good to go. Thanks for the tip.
So
you have a question?
No, just continue.
So we go ahead and say, okay, whatever we did, we have the C equals to 1,000. Some of those might not make any sense right now. Number of degrees, explanation, epsilon, the gamma and all that. But in this, if you go into this link I sent you, you should be able to get some information on how those are being categorized or aggregated. Now we want to go ahead and test the model. Now, score returns the coefficient of determination, equals R to the power of 2 of the prediction. Okay. Now this will be for the linear regression model, which in this case is going to give us, let me go ahead and post that and then run it again. So SVM confidence is going to be 0.998. Okay. And then we go ahead and train the linear regression. So and then we compare the two. The linear regression is this one. The variable LR equals to linear regression. This is just basically a function we call. We just return a function with blank, no parameter, and then we run it. Okay. Once you do that, then we go ahead and call the we do the training. We now take that data and then we train the models to see what it brings. So training. So linear regression, that's good. Tells us X true, the fit intercept true, and of course all that. And then once we do that, then we test the model. Now, whatever we tested up there, we are going to do the same here with the linear regression. Now, score returns the coefficient of the determination R to the power of 2 of the prediction. Now, less better than this one will be less better than this one, based on the calculation. So we run this one. Now compare this number and that number. These are pretty close. 0.998 and this 0.998. So in this case, the linear regression and the support vector regression are pretty close to each other. So that gives us a way of thinking in terms of which one is best and which one is close to being accurate. Remember, the closer you are to number one, the accurate you are. The farther you are from that number one, the less accurate you are. In this case, number one is going to be 1.0. So 0.998 is closer to 1 than 0.996 or 3 or 2. Okay. So we go ahead and say set X focus equals to the last 30 rows. 30 rows being the 30 days. Remember what we declared up there? Okay, sorry, that's number one. So let's go ahead and do for one for now. This is for 30 days, but we can do that for one because remember this variable stands for the number of days, which is already, it's a constant. So we put it in there. So if you run this one, it's going to give you number one. But if you want more accuracy, you probably want to go do more. So we come here, we change that to 30, and then we run it. Okay. See it.
Hey guys, I have to run. I will I wish you the best. I am looking forward to going through the notes when you send them.
All right, no problem. Thank you.
No problem. Thank you.
Okay, now we change that to 30 and then we come back here. Now we run this again. So it's going to give us 30 days. Now that's a focus for the X focus, okay, the prediction. And then we print the support linear regression model for the number of days, which is 30 days. So we go ahead and do that. So this is going to give us the linear, and this is going to give us the support vector. So if you are to make a decision, say for example, you can go ahead and plot this in a graph, and also plot this in a graph, and then put them side by side. Or you can import this into, let's say, pandas, or if we use maybe another library called Seaborn, then we generate a graph. For a graph, it's going to be easier to visualize and be able to pick which one is better in predicting than the other one. But if you look at these numbers, there's a very slight difference. For example, here we have 173 for the SV, and then this one here, no, this is for L. This is the linear, 173. This one is for the SV, this 172. So if you look, some of them will be very close, some of them might be the same, but this will make a decision will make somebody higher up make a decision on what they need to do in terms of the stock prices. And that's for building a stock prediction program. So that comes to the end of this particular slide. If you have any question, please feel free to ask me before we go to the next one.
I'm good, George.
All right. So I'm going to assume everybody's good. Okay. So we're going to do the next one. Now, this one is very interesting. We call it the rainfall prediction. Again, everything depends on the data. You can predict all you want, but if you have bad data, it's going to throw you off. The data depends also on how clean they are. We have to clean the data. So this one, we used a national weather forecast. So we downloaded the data and then we brought it on. This is for Austin, Texas. We can do this for Nairobi. We can do it for, let's say, Johannesburg. We can do it for Lagos, Nigeria. We can do it for Dallas, Texas. Depends on where you load it from. So before we do this, we use linear regression to predict the amount of rainfall. Linear regression tells us how many inches of rain we can expect. The rainfall prediction is the application of science and technology to predict the amount of rainfall over a region. That determines the rainfall for effective use of water resources, crop production, and pre-planning of water structures. So this can be good for a politician, can be good for a farmer, can be good for policymakers, can be good for a scientist, somebody in agriculture. It can be good for somebody in that platform where they have to make a decision. It could be for personal or could be for public. But in order for us to do that, again, you have to get the right data. So the data we got might not be very clean, but let's see what we have. So we downloaded the data. Then before we do that, we have to do the import of the libraries we are going to use. We are going to import pandas, import NumPy, import Skyline, sklearn. We import sklearn linear modeling, which is linear for linear regression and also for statistics. And we also import matplot library, which is going to be for plotting the libraries, which we are going to get as a result of this data. So we're going to be able to see some of the visualization. Now, before we do anything else, we have to be able to have the data. Now, what I did, I went ahead and uploaded this data beforehand so we can save time. So we read the data in pandas. Once the data is read, and then we drop or delete the unnecessary columns. So when I downloaded the data, let me see if I can get that here so I can show you. The data was not very clean. Okay. Data sets. Okay, let me go back here and share this other screen so you can look at the data. Okay, this is where I got the data from. And when you look at the data, this is the data they have. This is from kaggle.com. The data is subdivided into dates, the temperature high, the temperature average, temperature low, the dew point. Okay, we go on and on. I think it's keeps on going. It's a large data set. Some of them will be zero, some of them will be none. So that's where just mark this particular one right here. This is where you can download it from. Okay. So once we do that, then we go ahead and there are certain parts of that data which are not relevant to what we want to use. One of the aspects of that data will be the events, the date, the sea level pressure high in inches, the sea level pressure low in inches. So go ahead and delete or drop the unnecessary columns in the data. So we go ahead and do that. So we drop that. Then some values have T, which denotes trace rainfall. So we need to clean that. And we need to replace all occurrences of T with 0. To do that, we'll use, for example, this aspect of regular expressions in pandas, which we are going to use. So we declare a variable known as data and then equals data.replace. So we call the function replace. So anywhere you see T, you replace it with 2 zeros, which is 0.0. So it's going to go and do that across the file. Once we do that, then we say the data also contains underscore, which indicates no data cleaning. Which indicates no or nil. Now this means that data is not available and we need to replace those values as well. So we do another data cleaning. So we call the same variable, declare the same variable data, and then we say data.replace. Now when you see any dash or underscore, replace them with 0.0. So those are as good as 0, because we just need the numericals. We don't need any other special characters in there. So we save the data in CSV file. So we save it as after it's already been cleaned. So when we save it under new name, which is going to be Austin underscore file.csv. So it's clean, it's good to go. Now, once the data is clean, it can be used as an input to our linear regression model. Okay. Now, linear regression is a linear approach to form a relationship between a dependent variable and the independent variable. Okay, this is done by plotting a line that fits our scatter plot the best we can get it with the least errors possible. This gives a value prediction on how much by substituting the independent values in the linear equation. We shall use Scikit library, which is sklearn. We use Scikit library linear regression model to train our data set. Once a model is trained, we can give our own inputs for the various columns, such as temperature, dew point, pressure, and all that, to predict the weather based on these attributes. Now let's go ahead and read the data which we just saved. So we declare another one. So remember how we call the same variable. We basically call it, then we override it with new stuff. So whatever we had before, we call it, but this time we call Panda. We say, Panda, now read for us this data, but we want you to read it because it's now in CSV. So read it as a CSV file, but save it in data. Once we do that, then the feature or the X values of the data, now these columns are used to train the model, okay? We use those columns to train the model. The last column, that's the precipitation column, will be saved as a label. So we go ahead and say, now declare X, and then bring the last column, which is precipitation, sum in inches, but drop it. So we say data.drop, we drop that where X is equals to true, which is 1. And then we say the output or the label, now we go ahead and say the X. We call the same precipitation sum in inches. We save it in Y. And then we do the reshaping into a 2D vector, 2D. Now we say y equals to y dot values reshape. So this is the x and the y axis. Now where it starts from, the x and the y axis, -1, okay, to 1. So we consider a random day in the data set. We shall plot a graph and observe this day. So we go back here. So let's go ahead and do that. You read it? And then once we read it, then let's go ahead and drop. We drop that precipitation sum in inches, and then we also assign precipitation sum in inches to y. And then once we do that, then day index. This is to consider random day in the data set, randomly. We shall plot a graph and observe this. So we go ahead and say day index for 798. This one, I believe you can use anything you want just within that range. So the number of days equals to I for I in the range of whatever y is, size of y. Yeah. And then we come and initialize linear regression classifier. So we say we want to go ahead and call the linear method. We pass no parameter, but we save whatever is in there to this particular variable, which is CLF. So let's go ahead and run this. And then now we go ahead and call the linear to initialize the linear regression classifier. When we do that, it will go ahead and train the classifier with our input data, which is already here, but it's going to be to fit X and Y. So we run that. Now the linear regression copy X true, fit intercepts true, n number of jobs none, and normalize equals to false. So those, when you go into your notes, like if you're doing research about linear regression, based on what I talked about earlier on when we got started, you'll be able to see some of the relationship of what they're talking about, like what is what, in terms of fit intercept, the job, the end job, and all that. Now, once we do that, give a sample input to test our model. So we give it a sample input, and this could be this is an array within an array. It's a list in Python. So we give that to NumPy array, and then we call the shape. So we go ahead and run that. Once we run that, it's going to run up to the next one. So this will replace whatever we have in INP. And then once we do that, then go ahead and print out the output. So the precipitation in inches for the input is 1.338. Now that's the rainfall in inches. Now we want to plot the graph of the precipitation levels versus the total number of days. One day, which is in red, is tracked here. So you'll see that in the graph. So we go ahead and do that so we can get a scatter graph. So when we do that, this is a scatter graph. Then the graph will probably be the precipitation trend graph. It's kind of like spread out, but it explains it here that the red, that plot a graph with the precipitation levels versus the total number of days. Okay, could be 30 days, 20 days, 10 days, whatever we have. One day which is in red, so see that day right there? In red, probably it's not visible. Tracked here has a precipitation of approximately 2 inches. So if we were to blow this big, then it can zoom into it, then you'll be able to see what it does. But what we're printing out here is based on the precipitation trend graph, the scatter of X and Y. I mean the days Y and the color is green. You can always change that if you want. Something else, so green for G for green and R for red. And then we come here and then do the scatter in days, get the index, the X and Y, Okay, and then we do the precipitation level, and then the number of days. So if you're into meteorology, maybe this will mean a lot to you. If you really want to go into the details, feel free to look at the website I shared about the data, because this will probably be having a lot of information on how to translate. Okay. And then right here now, we go ahead and plot. We just show the PLT show. Remember, we call PLT up there, the plotting library. So when we run that, it's going to be able to help us get the average filter, the temperature average, the dew point average, the humidity average percentage, the sea level, and all that. So I'm sure if somebody in meteorology was to look at this, probably this will make a lot of sense to them. Now we plot a graph with a few features of X values against the precipitation or the rainfall. So we click on that. And then that gives us precipitation versus selected attributes. So we have 6. 1, 2, 3, 4, 5, 6. So those will mean something. If you look at the data, what we extract here. 1, 2, 3, 4, 5, 6. So those will mean something. If you blow them up, I can't even read it properly from here, but I'll send you all the details. The first one on the left is temperature average. Second one is dew point. This is humidity average percentage. And this is, this will be sea level pressure average inches. Visibility average in miles. And this will be wind average. And I'm sure you can blow this graph maybe based on the scale you want. So that brings us to basically the end of this particular slideshow here, and I think it's been really a long one. So we're almost to the point. We have 5 minutes. If you have any question, feel free. It's a good time to answer. If you have any question, please feel free to ask.
Hey, Migot.
Yes, sir.
Can you hear me?
I can hear you very clearly, Ali. What's up?
Good. How are you?
I'm all right, man. I can't complain.
Yeah, thank you. Actually, I really appreciate this lecture and the program you have. I had a question on, do you have like a class that you run? Because I just started Python.
Okay.
I'm coming from a SQL background, and I kind of see data is everything, and I needed to get some skills from the Python side. So the last few days I've been trying to download the Python, the ID, what's it called? The idea, whatever. I downloaded that one, and I'm kind of still very new to all these things you're explaining, but I see you have the knowledge, and we can benefit from what you're doing. So what is your plan? I don't know if I'm asking the question at the right time, but sorry, guys. What do you have?
So I started, this is the third iteration of what I'm teaching on Python. And I have to admit that I started from top coming down, basically on the applications. I was actually thinking of maybe I need to put a lesson plan together and maybe get on board those people who are interested in learning, so we can get that going, and that will be like from the basics in terms of talking of Python as in let's say the variables, the data types, and going all through maybe the first of any introduction, the first 5 to 6 chapters of any introductory book to Python. But that's going to be in the plan only if I get people who are interested. So look
Okay.
at you are, and then if you can get maybe a few more people, then we can sit, and then we do. But it's going to be we can basically we can chop them into 30 minutes so that you don't lose the concentration. This was pretty long.
Okay.
Yeah. So if you know somebody else, then please let me know so I can put together a lesson. And then based on what you saw, you can go back to the basics, and then this will make a lot of sense to you.
Okay.
But like you say, data is key, because I mean, they used to say oil and gold. Now data is the gold.
Yeah, it's very true.
That's
It's
right.
very true.
So,
I-
go ahead, Ali.
Go ahead, brother. No problem.
No, I was just going to add that I'm also learning Python. And from what I've attended, this is the second session I'm attending from George. From what I can tell is that it's fairly advanced to what he's covering, which means that you have to do a lot of groundwork for you to get to a point where you're comfortable with some of the things that he's covering. So there's a book I'm using, and I can recommend it to you, Ali, to use. It's called Python Crash Course. It's actually very good in terms of fundamentals. Let me just show you the book on video here.
Yeah.
Can you see my screen?
You said Python
Crash course.
Crash Course.
Course.
Okay.
Yep. It's very good. It's very good. It covers the fundamentals, like George said. The first, I guess, 10 or 12 chapters are the fundamentals of Python, which will just help you get comfortable.
Okay.
That's a good book.
Are you guys from Kenya?
Yes, sir.
Of course, I am from Kenya.
Maraga, I can tell from the name. So we
I'm
good.
from Kenya too.
Okay, good. We good. Pande gani Kenya?
Nairobi.
Na mi got
Mi natoka pande za Lake Victoria.
Lake Victoria. Idinade.
That's not bad.
Okay, good. I've been in Eldoret for a while.
Okay.
Mm-hmm.
Right now you are here, right? You in Canada?
Yes, Nico, Minnesota.
Okay. Okay.
Yeah.
Yeah. Are you the one I gave books to? Like you
No.
wanted?
No. I think hatujaongea, nilikuwa naona tu hii forum ikiendelea, but I think today is the first day I joined.
Okay.
So, yeah.
Yeah, a lot of good content actually.
Mm-hmm.
Like what George is sharing is fairly advanced, I have to say.
Mm-hmm.
So George, how long did it take to get comfortable with this stuff? Just curious.
Man, I've been doing this for some years now, but you see,
For some years.
one thing, let me tell you, man, it's not gonna be overnight,
Yep.
I know. Yep. That's true.
and also you will never know everything.
Mhm.
So you have to keep on pounding it. But the best way to learn, you'll always learn, especially language, you always learn to keep on trying to speak it. And this is a good way. So based on this one, like I said, the training of the models and all that, you'll find more or less the same concept, unless you want to just do linear or just want to do one type or the other. But Python is easy to learn. If you are to ask me, when I went to college, I did not have to do it. I learned it on my own. In college, they teach us Java, and in the initial stages, they used to teach Pascal. But programming is programming. So long as you know one language and you have the heart and the time, you can learn any other language in programming.
I have a question. The challenging part, I know, for any training is getting the hands-on experience on whatever you are doing. And I know I have done a lot before, but if actually you're not really doing, or maybe, let's say, for example, you did Python, and if you're not using it at your workplace, it's something that you can easily forget. Um, what do you think, or what's your advice, what's your plan in terms of uh, having something that we can kind of use as a data set for a continuous practice? If, let's say, at my work, if I'm not using Python, and today I learn Python for the next 6 months or 1 year, if I don't have the data to practice with, it will be kind of something kind of wasting, I can say.
Yeah, so that's a good question. Let me see if I can answer it. Now,
Uh-huh.
when I first started programming, I started programming BASIC, like the old BASIC. They call it business all-purpose symbolic instruction code. Very old BASIC, which the Microsoft people had to come up with Visual Basic basically to dress it up. And I don't use that anymore. But based on that language, I progressed into Pascal. I went into C and C++. But some of them I don't even use anymore, but they're still at the back burner. Now I used to, a few years ago, I used to use PHP, which is also very close and related to Perl and C or C++. I don't use it currently where I work. Now I use JavaScript. I don't use Python, but I train Python because I like it and I think it has future, especially when we talk of machine learning and data science. So to answer your question, if you want to learn this and you want to get it real good in, you want to start from the basics, but make sure you think of a project which you can do from the ground up. Think of a project, do it from the ground up in Python until you finish it, and then that will be part of your portfolio. Now, if for some reason your SQL is not working for you anymore, maybe the company is laying off, or for some reason you just want to move on to something else, Python will probably be very handy when it comes to that, because Python will talk to SQL without any problem. As a matter of fact, SQLite is built in Python, and I had some examples I wanted to show, but due to time, I could not. Just like Oracle or MySQL or Microsoft SQL or PostgreSQL, all those are good. Those are databases. But the way to learn will always to get it once you get the basics, and then you build on it. Once you build on it, and then you create a project which is viable. Viable in the sense that it makes sense in the current situation, in the current world. For example, right now, let's say we are going towards the election here. And I can tell you they're hiring for Python programmers because it's good for data science. And you know, all elections and polling, it's all about data. Machine learning, data science. So the back end is always either JSON, CSV, Excel spreadsheet, but the best will always be a database. A database like as huge as, let's say, Oracle, Postgres, or MySQL, or any other which are available there to be used.
So George, I have a quick question. Are there some, side gigs somebody can find which, you can engage in to crystallize on the skills that you're learning?
Yeah, there are so many other websites up there. Like you go to Upwork, you go to freelance.com, or you just search Google for, there's another one, I can't remember the name, but it's remote work for Python programmers. You might not be able to get like what you're looking for in terms of, some people might need certain things which might take too much away from you, your time and your work. but sometimes you might be lucky to get something in your line which you can easily do. But those are some of the resources you can look. And the main thing you always want to be, your friend will always be Google. If you think about it, Google probably knows it.
I have a question.
Yeah.
I'm studying what you're teaching, machine learning. Do you have details on random forest and decision trees that can teach us?
Do I have details? Hello?
Yeah, something on random forests and decision trees.
Okay. So you want that in the notes, or you want that to be like in a book format? How do you want that?
Are you asking like a
Maybe you
similar
can
class
again
for
what you're
on
now
random
going.
forest?
Say it one more time, please.
Yes.
You want like,
Yeah, a class like this one on random forest.
oh, okay. So you want us to be able to cover that, right?
Yes.
Okay, that's a good idea. Now that you've asked for it, we can put it in the oven for baking. And then, so I mean, if you are going to be available, then we can do it, because we can do that random forest and decision tree. Remember when we do the sklearn, most of these libraries, they have those already built in, like the random forest already there in making the decision, or the decision tree, like if this then that. So all these libraries are there, but we have to be able to use them to be able to apply them in real life. So if it's something you want us to cover, I'll be more than glad to cover that.
We'll appreciate.
No problem. So I'm gonna say random forest and decision trees, right? That's in data.
Yes.
So are you currently enrolled in school, like you're doing data science?
Yes, I'm doing data science right now.
Okay, where is that at?
I'm doing it online from Lambda School.
Okay.
Yeah.
That's good. We can do that. Are you familiar with the R programming language?
No, not yet. I haven't covered that. I did. I had taken a boot camp, but they didn't cover it in deep details. Just like pass it through. So I didn't get it then.
So the Lambda, are they teaching your data science predominantly in Python?
Yes.
Okay. Okay. This is your first semester, right?
It's actually they're doing it part-time for me. So I'll be like doing it like for almost 2 years, because I'm doing it every week, but for 3 hours.
Okay. So I'll see if I can. What's your email? Maybe I need to share.
I send my email. It's Waridi, the one.
Okay.
I put it in the chat.
Oh, you did already. Okay, I'll grab it from there. Yeah, let
Yep.
me grab it from there. Yeah, we can. Go ahead, please.
Yeah, another thing I think, and this goes to Mariga and Rose, just in case we are on the same level on Python, as I said, I'm just starting it, so I might be just novice on Python, but if we can just have something, maybe, like a group where we can get together in a week twice and help each other. I think that's one way we can progress slowly. I know people are busy, but if we put the commitment, if we have the commitment, I think we can get somewhere. So if you guys feel maybe something like that works, I'm ready. Just let me know.
I have no problem. I agree.
And
Yeah,
that'll be
Maraga,
sounds good.
wewe ndio utakuwa mwalimu.
Mimi. I wish I could be mwalimu, but there's actually the book I shared is very good.
Okay.
So,
Yeah, even something like that, sharing and directing somebody on where to get the resources is helpful,
Yeah, I'm happy to share where I can.
Okay.
Me too.
Yeah, just like George said, I think practice makes perfect.
Mm-hmm.
So the more we can practice, definitely the better we can get at it. So I'm all good. The only problem I may have is availability in terms of time, but that's something we can try to put on the calendar.
Anyone who is in Minnesota?
I can ping you my email.
Okay, no problem. I think I saw your email.
No, I didn't put it.
Oh, okay.
That was somebody else.
So anyone in Minnesota here?
I'm in St. Louis.
St. Louis, that is
Missouri.
Missouri. Okay. George?
I'm in California.
I'm in Dallas.
Dallas. Oh, okay.
Yes, sir.
So different regions.
That's right.
Yeah.
Well, Dallas and Minnesota, same time zone. And
Okay.
Missouri, I think. Yeah.
Right now it's 6 o'clock here.
Yep, as to 6 o'clock, 6:14 rather.
Anytime you have like a question or anything, feel free. I mean, I'm always available. I will also save your emails, but sometimes you want to catch it before you forget. So you feel free to just shoot an email and then see. And let me tell you, one person cannot know everything. So sometimes,
absolutely,
yeah, your question might just be able to bring us something which is totally new.
Okay.
Yes, sir.
Thanks so much.
Thank you. Any other question? Any comments? We covered 3. Sorry, we could not cover 4.
What was the other one, by the way?
I had a beautiful soup email extraction, but I'll send it to you guys.
Okay.
Yeah, how you can actually go in and basically web scrape information regarding, let's say, a website for national weather. You bring the data on your side. You can say create some kind of web app whereby if you want to know the data for Nairobi, just click, and then maybe not that one for maybe Kampala. So I mean, it's pretty good. Or you can scrape the data for like a stock market. For let's say Nairobi Stock Exchange, or for let's say Shanghai, China, or New York Stock Exchange. So Beautiful Soup is very powerful, and we use it in addition with requests, which is the library basically reads in the HTTP request from a website and brings it over, and then you can basically, instead of like right click, go to source of a web page, you can use that to bring it to your end, save it in the local drive or local variable, and then you manipulate it. Clean it, then you can make it much more functional. But I'll definitely send that to you guys so you can have a look.
Okay.
So is there a prerequisite before I do Python?
It looks like you're already in the you know the keyboard, right?
Yeah, that's the only prerequisite, Ali.
Okay.
So you've already covered pretty much what is needed. But as we go along, what other language have you worked on other than the SQL?
I did a little bit of C#, but not really that much. And HTML, CSS.
Okay, so HTML and CSS, like HTML,
The front side.
it's a markup language.
Yeah.
For the structure of a website, and then the CSS will always be like for dressing up of the HTML. Now the language here will be the C#. Now every programming language has 3 constructs. It's always going to be like the sequence, like it goes in sequence like a recipe, and then it'll be like the iteration. There'll be like the decision, where you go if this or that, otherwise this, right? And also have the loop. The loop is the iteration. Those 3, those exist in a programming language, and you've done that programming language, then you can do Python.
Okay.
Just a little bit of variation in terms of how you implement it, but which is not a big deal.
Okay. Yeah, I got you.
Yes.
And
So-
there's
so-
Ito on the call, right? Is that
Eto?
Tabu?
Yes,
How are you?
I'm fine. How are you?
Good.
Sorry I was late, but thank you for what you're doing, man.
Yeah, not me, but George.
We're in this thing together, man.
I appreciate it.
No problem. Where are you at?
I'm in Dallas.
You're in Dallas? Okay.
Mhm.
We're in the home ground there.
Oh yeah.
I'll share. I know you missed it, but I'll share the video, and I will
Okay,
also
thank you.
share the notes. This
That's
time
good.
around, we
Appreciate it.
had a lot of less notes and more video.
Okay,
Yeah.
that's fine. Thank
Just
you.
because you will be able to have more questions. If you have any question, you feel free to just shoot it to me directly, or you can put it out there in the forum so you can share with other people.
So quick
All right.
one, George.
Yes, sir.
What IDE do you recommend better?
Now,
I know there are quite a few out there
Mhm.
and can easily be confusing to a beginner.
Yes. So there are so many IDs you can use. The one which is very close to what you're going to be working with will probably be PyCharm, which you can download and install. But you don't have to download that. Instead, go ahead and download Anaconda. Anaconda is integrated ID with so many other IDs in it. If you download Anaconda, Anaconda will give you PyCharm. Anaconda will also give you Xcode. I mean, not Xcode, but VS Code, which is Visual Studio Code, which I really like a lot. Anaconda will also give you Notebook, which is very easy to work with. If you cannot do that, then you probably want to go online, just go into Google and type the word Colab. And then you can sign in, you'll be able to, you will not have to install anything, just work from Colab. And then you can save and download whatever you do. Let me see if I can share that screen so you see what I mean. Okay. Okay, so Colab will be one of these. Like right now, if I wanted to share this, I can basically just go and share there. And I can say, click on that, loads it up, and I just say, that's you right there. So I can
Yep,
send
that's
it,
right.
and then immediately you will be able to click on the link and you can edit it, or you can change it, or you can do whatever, or you just copy and download it. Now, if I do not want to do that, say for example, I typed it in here, which is, this is a notebook extension. I can instead go here in the file, click on file, and then download it as a Python file or as an
Binary.
yes. So this is for notebook, but I want to download it as a Python, so I can download it there, and then for me, I get it's a Python file, so I get a security alert. I say discard, or I want to keep it. So when I keep it, I just go in here, and then I can say, go ahead and open it. Then I can, once I open it, then I can have it here. This is the same file. So the good thing with PyCharm, you can go into, of course, PyCharm or VS Code, you have the terminal available for you. But if you go to Anaconda, you'll be having more than what you even bargained for. It's going to be a lot of interfaces you can work with. There's Jupyter, and there's a notebook also in there. You can also use R if you want to learn R. They're all in Anaconda. Yes, sir.
Yeah, maybe for somebody new to Python and programming in general, that may be an overkill.
Yeah, for the newbies, I would probably recommend Anaconda. It's easy to work with, yes, sir. Or this one right here, Colab here. Yes, sir. Any other question?
I think I'm good. I'll be dropping here now.
All right.
Yeah, thank you all.
Thank you.
Rakamano.
Yay. Welcome.
All right.
All right.
Bye.
Thanks, everyone.
Thank you. guys.
Okay, thank you.
Thank you,
Bye-bye.
everybody. Bye.
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 Okay.
It's